Okay, so there's actually a lot that we can say about this. It looks like a complicated object. There's a lot of intuition to be gleaned. So let's do that now. Yes?
So the invertibility condition then is that you don't use a lot of your own production, right? Because it's one and one in the, right? Or
So, right, so suppose you only used your own intermediate inputs and you didn't use either of these factors, then you would have a whole row of this I minus phi being 0. And so you would have a problem. But this generally is a very easy thing to invert for actual industries in practice because they don't do that. Any other questions?
Yeah, I have a question.
Yes.
Last week, I showed everybody a breakdown of, we took a particular industry, more or less grocery stores, and I showed them a breakdown of how much of the costs of $1 spent at grocery stores comes from farms
Okay.
versus everything else.
Mm-hmm.
Is that thing represented somewhere here?
Yes, it is. I think we'll see that in maybe 4 more lines of stuff.
We can wait.
Yes, yeah. So we'll get back to this point. The first thing I want to say is, does everyone see now actually how this equation actually looks a lot similar again to this equation? So it's kind of, it's by assumption of 2 inputs over here that we have 2 prices here. But at least at the industry level, if we take one industry, this is a matrix. That's the number of industries times the number of industries. This is a vector, which is a column vector, the number of industries by 1. So both of these objects multiplying these factor prices are industry by 1 vectors. And so if we write this industry by industry, you're going to get equations that look like this. The change in the industry's price is going to be this kind of complicated share that looks at this I minus phi inverse times the share and takes the ith row of that. But it really is the same equation. Does anyone want to guess what these shares sum to? So if I consider this as 1 share and this times this as another share, what do those sum to? Do they still sum to 1 as they did over there? Or do they sum to something else? So they actually do sum to 1. Let's show that. And the easiest way to show that really is just to guess and check. Okay, so let's guess that I minus phi inverse SI plus S1 plus S2 equals to, this is how I'll write my bold 1. We could just write a 1 with a vector above it, but okay, left multiply both sides of this by I minus phi. That's going to give us S1 plus S2 equal to I minus phi times 1. What's this right-hand side going to be? Well, it's just going to be 1 again, minus. Now we're going to sum the rows of the input-output matrix. And is everyone clear what those sums are going to look like? It looks like I've covered underneath the algebra that I need here. So remember this guy is I by I. This guy is I by 1. So the way the matrix multiplication is going to work is we'll take a row of phi and multiply it by a column of 1s, which just means summing up the rows of phi. And so what is the sum of the row of phi? Well, it's the sum over j of phi I, where I is the row. And then what's left really, just by the way that we've set up cost, is under here. So we have all of the spending on your intermediate inputs relative to your cost. We have all of the spending on your factors relative to cost, and those all add up to your cost. So in terms of shares of cost, the share on these inputs plus the share on these inputs plus the sum of all the shares on these inputs equals 1. So if we take 1 minus the share you spend on all of these inputs, then what do we end up with? We end up with precisely the shares that you spend on the other inputs. Is that clear to everybody? So this is 1 minus phi 1, which we just talked about. And that is true, really, by definition of the cost function. Is that clear to everyone?